All right, couple of things. An announcement for Monday. I thought we were going to do class via Zoom. There is not going to be class at all on Monday. Okay, they moved my stress test up from 2 o'clock until to 11 o'clock, so it's right in the middle of class. So, yep. Okay, so there'll be no class on Monday at all. Tuesday, there's not going to be a new lab. I say that. Wow, what happened to File Explorer?
Have you made a decision about one?
I have not made a decision about 115. Sorry. I have lost my File Explorer. Isn't that interesting? Hang on just a second. I want to check something out. And then I will continue on. Hey, that was not what I wanted. Apparently not. Apparently not, Matt.
Government's restricting your internet access.
Yes. How do you get to, how do you get, there we go. Okay. I just want to check something out here before I make another gaffe. Oops. Yeah, so on Tuesday, I was absolutely right. We will not be having a lab on Tuesday, okay? But what I am gonna do instead, you're gonna have a retest on Wednesday, okay? So I'm gonna use Tuesday to go through examples that you guys ask. I'll do a whole review session, okay? So it will be a required time frame for you to be there. You will need to be there. We won't start at 8, okay? We can start at 8:30 or 9 or whatever you guys say you want to do. Matt?
Retest
For this last exam that we just had, I'm giving everybody, so the class average, I just finished grading all the off-campus student stuff, and they raised the class average to a 76 from a 74, but it's still not where I like it to be. So you need to somehow jot this next piece of information down, okay? You need to bring in on Monday, okay? Or you can scan it in and submit it that way, but I want it for Monday. I want your first prelim and your second prelim, okay? I want your first, hey, Luke. So for Monday, I want your first prelim and your second prelim. The reason I want these, okay, is because what I usually do, and I didn't do it this time, particularly in prelim 2, is I didn't go through and say, okay, everybody got, or a majority of people got question 3 wrong, so I'm going to throw that one out, okay? Or the majority of people screwed up on question 8, and that's something I really want to retest you on. And the reason I want your first prelim as well is because I'm going to do that same thing for the final exam. I'm going to go through those problems and say, where did people really struggle, so that the review sessions that I do for the final exam are more focused on the things that everybody had a problem with, okay? All right, so and the people that are off campus, if you're seeing this video, you don't have to send me anything because I have all your stuff electronically anyway, but I want everybody's prelim 1 and prelim 2, okay? Any questions on that? And I want those for Monday, Wayne. No, I want you to bring it in. I want you to bring. Oh, sorry. Yeah, Tuesday. Yeah, sorry. Sorry, I've been saying Monday. I apologize. Tuesday, when I'm back on campus. So during that lab section, okay, I want everybody to bring in their prelim 1 and prelim 2. Okay? All right, cool. All right, how you feeling, Luke?
So.
Yeah, you don't look like you have any energy there. All right, so you caught all that. No class on Monday at all. Okay. And on Tuesday, not Monday, thank you guys. On Tuesday, Nizali, can I have you sit in this seat only because I can't see Wayne when you're sitting there, and I'd really like to see everybody. It's not that I don't want you sitting next to Matt. I just want to be able to see everybody. So you'll have a retest on Wednesday. Okay. You'll have a retest on Wednesday. And we'll talk about you, and you probably know, right? Based on that review that I did, you may not have seen it yet, the recording, because you weren't here that day. The prelim 2 recap video, you really ought to look at that. That should be like prime for your studying, that and homework and stuff like that. But that should really be prime. I want you guys to come in on Tuesday armed with questions. I'm gonna give you the opportunity to get another 10 points on this exam, at least, maybe even more.
So if there's a retest during class on Wednesday,
Mhm.
if you're not gonna take a retest, should we come to class that day still?
No, you don't have to come to class if you don't want to do the retest. Yep. Okay. But there will be a retest on Wednesday. Okay. And the reason I'm not doing it on Tuesday during the lab section is when I really want to do it. I need to do some time reviewing with you guys. I really do. The other potential possibility is do a review Monday night online. Wayne, can you sit back? Because I can't see Braden. Yeah, sorry. The other potential option is we do the retest on Tuesday, like second half of lab, and Monday night we do a review on Zoom.
I like the original plan.
I know you do, because you guys don't want to do new material, but my problem is we're running. Yeah, no, I get that. Yeah, I get that. Okay. Right.
Format test, same length. question
No,
style.
not the same length. It'll be a lot shorter. It'll be like 3 or 4 questions, not 10 or 12 questions. It'll be 3 or 4, and it is gonna focus obviously on the places where people struggled the most. I can tell you one problem, the voltage divider circuit, people really needed some work on that. Short circuits and open circuits and the circuit redraws are the 3 that come to mind immediately, okay? Right. You are not required to retest, okay? You are not required to take a retest. And the retest cannot hurt your grade. It can only help you, okay? Can only help you. I will not, if you get a 0 on the retest, I will not, take off 20 points. It's just not gonna happen. You guys want the grade. I need you to know the material. So we gotta do some things. I'm not gonna do a Monday night review. We'll do it live. We'll do it live on Tuesday. Let's say lab starts at 9. Okay? It isn't lab, but it will be the class that starts at 9. And I will answer whatever questions you guys have. And then I'm gonna kind of set the second half of the time frame for everybody, including the off-campus students. Ask whatever questions anybody wants to ask. But I need you guys to do some work up front too, okay? I need you to look over your prelim 2. I need you to look at that prelim 2 recap session, okay? And go through that, okay? But again, yes, Matt, you don't have to do any of it if you don't want to retest. Okay. Okay, any questions on any of that? Sorry, that was a lot of blah, blah first thing in the morning, wasn't it? All right, as I just told Hunter, I am gonna start you from scratch on this, okay? Because I was shoving it down your throats pretty quickly. All right? So generally, when we label these things, we label them in clockwise rotation. So I'm gonna call this R1, R2, R3. Green is not good. Let's go with that blue again. Okay, R1, R2, R3. And then we look at on the delta, we have a tendency of calling, depends on how you draw it. I would call this RA, RB, RC. So this is also R1, R2, and R3. And you may have heard us talk about, or other students talk about, Y and delta, okay? These are power cable configurations, okay? So you may have a delta connection on a transmission line, or you may have a Y connection on a distribution line. For our purposes, we're going to use it to help simplify complex geometries with resistors and things like that. For instance, problem 867 has a resistor, and I'm going to go through this problem, has a resistor network that kind of looks like this. And then it has a whole bunch of other things going on. How do you resolve this? Well, as it stands right now, it's not a big deal. You could see if that's all there was, right? It'd be these 2 in series and this in parallel. But if we've got other things going on, right? Not so simple. Right? And we're gonna take a look at some of these to see how we can make it a little easier for ourselves. Okay? Where we're going. All right, so let me start again with to convert. To convert from, and you probably have this in your notes, delta to y, each y arm is the product, that's supposed to be an m, is the product, I couldn't even read it, is the product of the two closest delta arms divided by the sum of all the delta resistors. So if, for instance, we have a delta circuit, and I'm going to draw it this way. I have this right here. I have RC, and I have RA, and I have RB. I am going to call these points associated with this. Across from the RA, I'm going to have an A point. Across from the B, the RB, I'm going to have a B point. And across from RC, I'm going to have the C point. Okay. What we can put inside of this is the following. So I'm going to put a dot in the center here, and I'm going to create a Y inside. So I'm going to come from A to the center. I'm going to come from B to the center, and I'm going to come from C to the center. Okay. What's connected to my A point is going to be R1, and going clockwise around this, R2 and R3. Okay. And so we want to go from that black triangle to the red Y. And so to calculate that, R1 is going to equal the product of the two closest delta arms, which is B and C, RB, RC, all over the sum of all the delta resistors, RA plus RB plus RC. R2, what's going to go on top for R2? RA and RC. So we're going to have, because we're looking at R2, right? The two closest on either side of it are RA, RC, and it's still going to be over RA plus RB plus RC. And R3, A and B. Yep. Good. Okay. Hang on, I want to just scroll down here for a second. All right, so I'm just going to do an example that's not even on here. Okay. Yeah. Let's do a delta to a Y. If I have a resistor network that looks like this. Okay. How would I convert this to a Y? Let's call this 10, 8, and 6. So what I want to know is, how would I convert this to a Y? What would the resistor values be for R1, R2, and R3? Do those calculations for me, please. I literally will label each one of these things. Oh, that's the other thing I wanted to say about the retest, and I'm going to say it probably another 17 times between now and Wednesday, okay? If you get the right answer, but don't show all your work, it's going to be a 0. Okay, there'll be no points added. Okay, I need to make sure everybody knows that. A lot of people throughout on campus and off campus made a lot of mistakes because they didn't draw out the circuits. And then I had a couple people who just did a phenomenal job writing out every circuit. I had a couple of PI students and the person at UTC who did a great job, and to a point where I'm going to show you what I want for work. Okay. Right. But I mean it. Doesn't matter if the answer is right or not. If you can't bring it back and show someone else how to do it or how you got there, it has no value. Okay. And the extra 10 points is even if you got 100 and something on the exam, you can still get another 10 points. Okay. And like I said, it might be even more than that after I look at all your exams and see where people had the biggest issues. Okay. All right. What'd you get for R1? What's on the top? What's the numerator? Paul. Paul,
Hey there, I was just gonna say,
you need me? What?
no, I was just gonna see, you were doing something, you would need to run.
How we doing? Yes, it's gonna be 6 times 10. 6 plus 8 plus 10, which gives us what? That's fine. 60 over 24. Anybody got that?
Yeah.
What's 60 divided by 24? 2.5, 2.5 ohms. Okay. We're gonna redraw this, so let's calculate all of them. R2 is gonna be what in the numerator? 8 times 10? Okay, so what's 80 divided by 24? 3.3, we'll just leave it at that. And then R3 is gonna be 6 times 8. Oh, we can do this one. 48 over 24, woohoo! Is equal to 2 ohms. So let's redraw this now, okay? So I'm gonna keep my A, and I'm gonna have something that looks like this. And this is B, and this is C. So this is R1, so this is gonna be your 2.5 ohms. This is your 3.3 ohms. And this is your 2 ohm. Now, when you look at this, what the heck do you do with that B that's just hanging out there? If I have a voltage source that's sitting here, can't. It's a good thought. You can't. It's just hanging there, right? So when you're trying to solve for a simpler circuit here, this is probably not the best one to use because this one with current, I'm only going to be using the 2.5 and the 2, right? Whereas look at what I had originally. I had A, I have a 10, I have an 8. Thank you, Matt. I appreciate it. And a 6. Okay. So Paul and his kid just danging. Yeah, that's what I figured. Yeah. That's why I didn't holler down the hall. So where would I do with this? If I have a voltage source attached here,
Oh, you just put it in series.
10 and the 8 are in series, right? So couldn't I redraw this circuit so it just looks like this? A, and here is my C, which is 6, and then this would be 18, or I can draw it like this. I can do 10. Okay, slow down. You know, that's me I'm talking to. There we go. One step at a time. This becomes the 10. This becomes the B. This becomes the 8. How's that? Is that a little bit better? So then we have that voltage source, 6 and 18. So the 6 and 18 are in parallel with each other. Okay, so in that sense, it's a lot better to leave it just the way it's at. So don't make it harder than it has to be, unless I tell you, convert that. Okay, change that to a Delta-Wye, change that from a Delta to a Y configuration. Okay? All right, questions on that?
Oh, well, okay. So this will still work though. It will still work the same as this.
Yeah, it does.
This-
It comes out the same, yeah. But you don't see it. We are all the same. I see that hanging and I go, oh, what do I do with that? But what Nizali's saying is the current that's coming out of here is still going to be the same as the current coming out of here. We haven't changed the circuit. We've just changed the way it looked. Okay, so I did change the circuit. We haven't changed the values or what's going on in the circuit. We've just changed the way it looks. Okay? Questions on that? But it's a neat concept. I mean, there's no question about it. But most of us have a hard time going, well, what do we do with it? Leaving something hanging just is not natural to us. Matt? Mm-mm. It's not connected. There is no connection there to anything. That is a total open circuit,
So
total open circuit.
the converting, since in this case, it'd be easier just not to convert it.
Yeah.
Um,
If I originally had given it to you as a Delta circuit, yeah, I wouldn't have converted it.
That just to like get to a certain set of steps.
It's to get it to something that you recognize.
Okay.
Yeah, it's to get it to something that you recognize.
Easy enough.
Yeah, like I said, I'm hoping we're gonna get to problem 867 today because that will make a difference. Okay? All right. Let's go the other way. Okay? So going the other way. From Y to delta. Okay? Each delta arm is equal to what's called the sum product. Is equal to the sum product, and I'll show you what that means, of all resistor combinations divided by the opposite resistor. And again, I'll show you what I mean. All right, so if I start off this way, okay, I'm going to start off, I'm just going to stick with my original diagram, okay? So I got RA, RB, RC, all right, and R1, R2, R3. I'm going to go back to that. So I'm going to have A, and this is resistor 1, and I have my center, and this is B, resistor 2, and this is resistor 3, and this is C, okay? And we're going to try and get this red diagram to this. And what is this? What is the lettering for this one? R what? It's opposite C. So what is it going to be? It's going to be RC, okay? This one's going to be RC. That's what it's opposite, okay? This part of the delta leg is going to be R what? RA, because it's opposite the A point. You see why I put the points in there? And this is RB, it's opposite the B. All right, so RA is going to equal the sum product of these resistors. So RA, which is this one here, is going to be R1 times R2 plus R2 times R3 plus R1 times R3. It's the sum product of all those resistors. So you have a 1 and a 2 and a 3. They have to be multiplied with each one of them. Over, what's the opposite resistor from RA? R1. RB is the same thing on the top, R1, R2, plus R2, R3. It's just all the possible combinations of those resistors. Okay? Over, what's the B opposite? 2. And then RC is going to be the same thing again, R1, R2, plus R2, R3, plus R1, R3, all over R3. Okay. Armed with that knowledge, please do example 1, finding RA, RB, RC, and knowing that RA is going here, right? Because I'm calling this, there's A, there's B, and there's C. So RA is going to go here, right? B is going to go over here. And RC is going to go here. So please calculate RA, RB, RC. Yeah,
The resistor right above R was 50.
this one is, let me do these inside again, sorry. I'll put them in blue. This one is 20, this one is 50, and this one is 40. Is that better? A little bit. And this is R1, and this is R2, and this is R3. All right, so what'd you get for RA? Say it again. 190. And RB? And RC? 95. You guys all agree with these numbers? So the redraw of that right there is going to be, there's 95, and here is point A. Okay, and then here, RB is 76, and RC is going to be, whoops, excuse me, this is RA, this is 190, and that is B, and that is C. And you could easily find the equivalent resistance for that, right? Because these two are in series, and that would be in parallel with the 76. Right? I'm not asking you to do that, so don't worry about it. Okay. All right, next thing. What if we have this awesome example where all the resistor values, sorry about that, guys. Is that better? Yeah. I didn't notice it until I saw you leaning in to see it. Okay. If all the resistor values are the same. Okay. Well, what we have is delta is equal to 3y, or 3y is equal to delta. Okay. Or y is equal to delta over 3. All right. So what does this mean? Well, we've got our A, our B, and our C. And what this means is that I can draw my delta, because this is a Y connection, right? Y, so I can draw my delta. And this is going to be, each of my delta arms is going to be equal to 3y, right? Did I say that right? Other way around, yeah. Each of my delta arms is going to be, no, it's got to be the other way around. Oh, no, I'm creating a delta. I think I've said this backwards, so hang on. I think I said it backwards and I just don't want to confuse you anymore. You know what? Calculate it. Do this. We're going from Y to delta. This would be a better exercise. Do this. Do one of these. Right? And it's going to be 60 times 60 plus 60 times 60 plus 60 times 60 all over 60. 180 on the top. Yeah, so it's 180. Wait a minute. If I take 60 out of each one of these terms, it's just 60 plus 60 plus 60. So it gives you 180 total, right? Yeah, okay. So 180. So I was right. Okay, I didn't say it backwards. So each of these, it's wrong in my notes. That's the problem. So each of these is going to be one delta arm is equal to 3 times your Y arm. If your Y arm is 60, these are going to be 180. Okay? Does that make sense? That's right. Delta equals 3y. Yes, because only when all resistors are equal in either the delta or the Y. You can use the same thing, only obviously in reverse. Only when all resistors are equal. If they aren't equal, then you need to use the R1, R2, R3, R2 times R3. Say it again. Come on, as a math major, you should love that symmetry, right? All right. What I want to do is go through problem 867. It's not on your sheets. Oh, wait, we have one more problem on this, don't we? Okay, sorry, my apologies. One more problem here. Okay, find our equivalent just the way it is. Guys, this is just an exercise in futility. Look at this and tell me how you would find our equivalent just the way it is. Can't. It's really difficult. You've got to, you just being able to try and do that the way it is would you can't. Okay? Because when you do this, even if I redraw it, what's directly in parallel? What's directly in series? I mean, you just can't. Okay? So we have to convert one end or the other of it. So watch what happens if I call this A, B, and C. What I'd like you to do is convert that bottom to a Y. So dot in the center. So do me a favor and convert that to a Y. Just the bottom part. You're gonna go from a delta to a Y. Yeah, I don't mind pulling that back up. You want me to bring that up on the screen? Delta to a Y. Right there, delta to a Y. The arms around it over the sum. That's what I call it. I don't say the two arms that are on either side of it. I say the arms around it over the sum. Okay. So first things first, if this is R1, which one's R1? You tell me.
The one that's
Right here
right behind.
or this one? Yep, first one. Okay.
And those-
Yep, and this one is R2. And this one's R3. Okay. So R1, which one is RC, RB, and RA capital? Which one, where's RC? Yes. So there's RC, right? This one's RB, and this one's RA, right? Okay. So R1 is equal to what? Give me the in letters or numbers or whatever, either one.
3 times 6 divided by 12.
Yeah, so it's gonna be, R1 is gonna be the arms that are around it, 3 times 6, all over the sum of all the resistors, 3 plus 6 plus 3. Yeah? Equals 18 over 12. Yeah? Okay, R2 is gonna be this one right here. You can't tell by the way I've written them, that's for sure. That's R2. R2 is RA and RC, the arms around it. So it's gonna be the same thing. 3, 6 over 12, which is 18 over 12. And how about R3? It's gonna be 3 times 3 over 12. This one is gonna be 0.75 ohms. What's 18 over 12? 1.5 should be. 1.5.
Yeah.
Yep. Okay, so now we're gonna redraw the circuit, okay? Because I'm all about redrawing the circuit, right? And what I'd like you to do is look up while I'm doing this, and I promise I will give you the opportunity to copy it. Okay, so eyes up, please. All right. So here's the redraw, eyes up. Okay, so here's the redraw. Here is my 4 ohm resistor. Here is my 2 ohm resistor. Here is A, here is B, and here is C coming back down here. We just said, and we've got a dot in here, R1 is equal to 1.5 ohms, right? R2, which is here, is also going to be 1.5 ohms. And then this is going to be 0.75 ohms. Now, go ahead and copy that, and then we'll do the next step. Yeah. This 4 and 1.5 and 2 and 1.5 are in series with each other, but those two legs are in parallel. Yes. And that's what we're going to do. Okay. Here's the next redraw. Whoops, that's 2. There's a B. There we go. There's a 1.5. Okay, and that's 4. And then they come together. And there's 0.75. Yeah? Everybody okay with that? Okay. Next redraw looks like this. I have, in parallel with each other, I have 5.5, and I have 3.5, and then I have 0.75. What is 5.5 in parallel with 3.5, please? I think it should be 2.14, but. Okay, so 5.5 in parallel with 3.5 is equal to 2.14. Here is the next redraw. I have 2.14, and I have 0.75. What is the equivalent? 2.89 ohms. You can solve for that circuit if it were attached to a power supply. You could come up with our equivalent, yes?
Yeah.
All right, so that's really the point, is to try and get this to a point where you can do something with it. All right, so not on the page at all. Here is problem 867. Oh, I'm sorry. Did you guys get a chance to copy that stuff down? All right, so here is problem from your book, problem 867. And it looks like this. Plus to minus 80-volt power supply. We have a 4K ohm resistor here. We have a 4K ohm resistor here. And we have another 4K ohm resistor here. And then from this point, we have, at this point, we have another resistor, but this one's a 6K. Is that a Y? Or a T? Yes. Okay. And the only difference, as you probably know, the only difference between a Y and a T is the position of the arms, right? All right, so if I have a Y connection that is this, and I still have, I'm going to call, let's see, which point did I call what? So I call this A, I'm going to call this B, and I'm going to call this C. From A to B, I also have that 6K ohm resistor. Okay. So what if I change this to a delta connection? Could you solve this problem now, just the way it is? If I asked you for the current through this 4K ohm resistor, could you solve it the way it is? Yes.
Yeah.
You could. You could. You could use mesh. You could use nodal, right? Okay. Right. I don't want you, the reason I'm pointing that out is I don't want you to forget all the things you do know. Okay? Right. So don't immediately jump to the conclusion that you have to do a source, do a resistor configuration conversion. Okay? But we're gonna. Okay? All right. So what is it? 1 delta equals 3Y. Okay? So it's going to make A, B, and C. It's going to be A, right? B, and C. Whoops, that's not a short circuit. That's going to be 12 ohms. 12 ohms. Whoops, 12K. 12K and 12K. Yeah? All right, so I'm going to redraw this. And I have got this right here, I'm gonna call this A still, and I'm gonna put 12K, and here is B, and I'm gonna do 12K, and I'm gonna do 12K. Where does C go to? Yeah, so it's just gonna come over here to ground. And then I also have a 6K resistor up here. Yeah? But you can solve this. What's in parallel? Give me just two things right now that are in parallel. The 6 and the 12 are in parallel with each other, right? But let's look at something first. Let's look at something first. Okay. Notice something here. Isn't B also connected to ground? Yeah. So we've got to watch out for that, okay? We have to watch out for that. In this circuit, that's one of the reasons it made it so difficult unless you use mesh to solve it. I'm just pointing out a short circuit because everybody screwed it up so badly on the exam, or the majority of people screwed it up so badly on the exam. Okay. Let's solve this problem the way we're going forward, okay? Yeah? 6 and 12 are in parallel. What is 6K in parallel with 12K? Now what has to happen? These are in series with each other, right? So I have, this is C, here is C. No pun intended. Are you seeing how I redraw these? Keep those dots in there, okay? 4K plus 12K equals 16K, right? So now I'm gonna have, there's A, and I'm gonna have, or I can do it like this. I can do 4K, and I can do, there's B, and I can do 12K. Why would I do it this way instead of just jumping right in and putting 16K? Yeah, because I may very well ask you, what's the voltage at VB, what's VB, right? And if you just immediately jump to 16, you may not see that. I am okay if you do see it, okay? But don't skip any more steps than that. Yeah.
Where does the B go out in the combiner?
The B goes away. You can't say what is the voltage, well, you can say what is the voltage at B because you go back to this diagram.
So it's supposed to be kind of scale.
No, so no, you can't do that, okay? So you can't say that. That's a great point. So let's solve this. Okay, let's keep going with this. And I'm gonna ask you, what is VB? Okay? Let's do that. It's a great question. So shoot. We're gonna do it. I'm gonna give you a quick rundown, or a relatively quick rundown. So plus to minus 80 volts. I got 12K and I got 16K. What is 16 and 12 in parallel, please? What is it? 6.6K? 6.86, okay? So I have 6.86, you said? Okay, 6.86K. All right, just those two in parallel. What's the source current? What? Source current. I is going to be 80 volts, all divided by 6.86K. 11.76 watts. Probably milliamps, or is it amps, or is it 6 amps? Okay. All right. No. It's got to be milliamps because that's divided by K. All right. So if I have 11.6 milliamps, what I have for a voltage across here and a voltage across here?
80 volts.
80 volts, because they're all in parallel. I have 80 volts here, right? So that says I have 80 volts from here to here. I have 80 volts from here to here. What is VB? How do you find it? Voltage division, so let's do it. Let's take this circuit right here. VB, which says it's the point from B to ground, is equal to the total voltage across there times voltage division, the one we want, 12K over the sum of the two, 16K. Don't lose those original rules. Please, please, please. VB is equal to 60 volts. Yes, no, maybe? Okay. Go forth. Thank you for your time and participation. Have a great day, and I will see you on Tuesday.
Have a good one, Jude.
Have a good one, Luke. I hope you feel better. Do you get to go home for Easter at least? No.